Good day guys, welcome to another video. Today's lesson focuses on a previous question paper. This is a 2025 June preparation exam paper 1. This paper will help you prepare for the paper 1, the June 2025 paper 1 exam. So let's run through the question paper. So the first question deals with numbers, types of numbers. If we go to question 2, we've got factorization in 2.1. 2.2 is simplifying. Question 3, we've got solving equations. Question 3 also is solve for inequalities, simultaneous equations, and then we've got graphs, drawing of graphs. Question 4 is drawing of a graph. Question 4.2 is another graph, a parabolic graph that we need to draw. And question 5 is interpretation of graphs, parabolic and hyperbolic. So let's go to question number 1. So for question number 1, they say determine the following without the use of a calculator. So 1.1 wants us to find out between which two consecutive integers lies negative square root of 69. So to answer this question, we have to know what square numbers are. So I'm going to list the square numbers. So the square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81. So why are square numbers important in determining or answering this question? Because square numbers, if you take the square root of any square number, you get an integer. So for instance, if you take the square root of 1, you should get 1. Square root of 4, you should get 2. Square root of 9, you should get 3. Square root of 16, you get 4. Square root of 25, 5. And so on. But realize for the given question we've got a minus, so we can just introduce minus here. Minus, 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 minus 1, minus 2, minus 3, minus 4, minus 5, and so on. So when analyzing our square numbers, we can see that, let me say when analyzing these radicals, we can see that square root of negative 69 lies between these two. So square root of minus 69 is between square root of minus 64 and square root of minus minus square root of 64 and negative square root of 81. So this radical lies between negative 8 and negative 9. So for 1.1.1, we can say that minus square root of 69 lies between minus square root of 64 and minus square root of 81, which implies that it lies between negative 8 and negative 9. So the next question says show that 0.9 recurring is equals to 1. So we know that 0.9 recurring is equals to 0.999 and so on. So we can set up a system of equations to show that these two are equal. So we can say let x equals to 0.999, continuing, call that equation 1, and we set up another equation, 10x is equals to 9.9999 recurring. So why did I set up this equation? I multiplied by 10 because if I subtract equation 2 from equation 1, these cancel out. Everything after the comma cancels out and you're left with 9. So let's subtract equation 2 from, equation 1 from equation 2. So 10x minus x is 9x, and 9,999 minus 0,999, these fall away. This leaves us with 9. So if you divide throughout by 9, 9 and 9 cancels, 9 and 9 cancels, therefore x should be equals to 1. So let's have a look at question 2. It says factorize the following expression. So in 2.1.1 we given 3x minus x squared. We need to factorize this. So you'll notice with the second term, x squared, we can write that as x times x minus and 3x. So you'll see for both terms, we've got x common, we've got 2 terms and x is common. So we can factor x out. So we're left with 3 minus x. And for 2.1.2, we've got x squared minus 9. So you'll notice we have a square number. So we need to apply dots, difference of 2 squares. So this can be written as x squared minus 3 squared. And this is x plus 3, x minus 3. And this comes from the identity a squared minus b squared is the factors a plus b and a minus b. So in 2.1.3 we've got a quadratic expression. So we can write that as x squared minus 4x minus 5. So when factorizing quadratic expressions, you expect 2 factors, x and x. And so the numbers that you choose here are such that when multiplying them, you get -5, and when adding them, you get -4. So let's list our factor pairs. -5 times 1 is -5, and 5 times -1 is equals to -5. There's no other factor pairs or pairs of numbers when you multiply them, they give you -5. So I said if you multiply these two, they should give you -5, and if you add the factors, they should give you -4. So let's see for the first one. -5 times 1 is -5, so it satisfies this, and -5 times -5 plus 1 is -4, so we choose this. So we can say it's -5 and +1. So moving on to 2.2, they want us to simplify, right? So for the first 2.2.1, we have m squared minus 64 over m squared plus 8m divided by m minus 8 and m. So the first thing that we want to do is we want to get rid of the divide. To do that, you need to flip these two, meaning the m should go on top and this should go, m minus 8 should go under. The minute you flip it, then the divide changes to a multiplication. So when we analyze the numerator, you can see we have a square number because 8 squared is 64. So it means here we need to apply the difference of 2 squares, right? And m squared for the denominator, you can split m squared. Okay, let's first deal with the numerator. So m squared minus 64 is the same as m plus 8, m minus 8. I've just applied difference of 2 squares, and in the denominator, m squared can be written as m times m So I'm just going to write this as m times m here, and then you can see m is a common factor. So here I've used taking out the common factor, right? So I'm going to factor out m, so it means we're left with m plus 8, and then here we have m over m minus 8, right? So m plus 8 and m plus 8 cancel out. M minus 8 and m minus 8 cancel out, and m cancel out. So our final answer is 1. So let's have a look at 2.2.2. We're given this expression. So we're given, this is an exponential expression that we need to simplify. 2n minus 1 multiplied by 8n plus 1 all over 16 to the power of n. So you'll notice for the three exponents, they all can be written with a base of 2, because we know 2 to the power of 3 is 8 and 2 to the power of 4 is 16. Right, so let's apply this information to the given expression. So we can see that 2 to the power of n minus 1 stays the same, and then 8 can be written as 2 to the power of 3 raised to the power of n plus 1. So I've essentially just replaced 8 here with 2 to the power of 3. And then in the denominator, 16 can be written as 2 to the power of 4 raised to the power of n. So this is 2 to the power of n minus 1 multiplied by, so if you have a power raised to another power, if you have a power raised to another power, you should multiply the power. So this is 2, and you multiply 3 with a whole power. So it's 2 to the power, or 2 to the exponent of 3 multiplied by n. So what you need to do here is you need to distribute 3, multiply it to n, and 3 and multiply it to 1. So this will be 2 to the power of 3n plus 3. And in the denominator, 2 to the power of 4, again you distribute because you're raising an exponent to another exponent. So you multiply. So you multiply. So 4 times n is 4n. So it's 2 to the power of 4n. So notice you have a multiplication here. So you can use the law of exponents that states if you have exponents with the same basis, or powers with the same basis, a to the power of a to the power of m, and a to the power of n, we can add their exponents. So it's a to the power of m plus n. So we can apply this identity to the given expression. So again, you can see we've got similar bases, so we can add the exponents. So this is equals to 2 to the power of n minus 1 plus 3n plus 3, and then the denominator is 2 to the power of 4n. So this is equals to, so n plus 3n is 4n, so it's 2 to the power of 4n, and minus 1 plus 3 is positive 2, and in the denominator we've got 2 to the power of 4n. So we can apply the identity that if you divide powers, for instance, you have a to the power of m and a to the power of n. If you divide powers with the same basis, you can subtract the exponents. So we can apply this identity, we can apply it here. So this expression then can be written as 2 to the power of 4n plus 2. If you take 4n up, it becomes minus, so it's minus 4n. So 4n and 4n cancel, 4n minus 4n, so we're left with 2 to the power of 2, which is equals to 4. So for question number 3, they say solve for the unknown variable in each of the following. So here we've got a quadratic equation. So this can be written as 2x squared plus x minus 3 is equals to 0. So we expect to have two vectors and two solutions at most. So 2x and x, when multiplying, they give you the first term. And then we need to also find a pair of numbers such that if you multiply, you get negative 3, and if adding, you get positive 1. So the two numbers that come to mind is plus 3 and minus 1. So let's just test to see if these are our factors. 2x times x is 2x squared. 2x times negative 1 is negative 2x. Positive 3 times x is plus 3x. And 3 times negative 1 is negative 3. So I just use the distributive property. So this is 2x plus x minus 3. So it brings us back to this. It brings us back to that. So it means that these factors are correct. So for these for this equation to be true, it means that 2x plus 3 should be equals to 0, or x minus 1 should be equals to 0. Therefore 2x should be equals to negative 3. This implies that x should be equals to negative 3 over 2, or x should be equals to 1. So let's look at the second equation. Here we've got a plus 1 into a squared plus 2a minus 3 is equals to a into a squared plus 3a. So the first thing we need to do to solve this equation is we need to eliminate all the brackets. So we need to distribute. We need to use distributive property. We need to distribute and use the distributive property. So on the left hand side, a times a squared is a cubed, and a times 2a is 2a squared. A times negative 3 is negative 3a. So I've just distributed a to the terms inside the second bracket. And then positive 1 times a squared is a squared. Positive 1 times positive 2a is 2a. And 1 times negative 3 is negative 3. So likewise, I've also distributed 1 to the terms in the second bracket. So let's reduce the right hand side. So 8 times a squared is a cubed, and 8 times 3a is 3a squared. So the next thing to do is to take all the terms to the left side of the equation. So it's a cubed plus 2a squared minus 3a plus a squared plus 2a minus 3 minus a cubed plus 3a squared minus 3a squared minus 3a squared is equals to 0. So I've essentially just took on these ones to the other side. I took those ones to the other side of the equation. So now I'm just going to use color codes to group like terms. So all terms that are cubed, I'll use red. So that's cubed. And then all square terms, I'll use purple. And I'll choose a different color for the terms containing A. Okay, I think, let me just, I skipped one here, A squared as well. So I'll just use maybe green or something. Or yeah, let me use that one for the A terms. And then 3, I'll also just use a different color. Yeah. So let's group like terms, or add and subtract like terms. So A cubed minus A cubed, these cancel out. 2A squared minus 3A squared. Okay, so it's 2A squared plus A squared is 3A squared minus 3A squared. So these cancel out, right? And then minus 3A plus 2A is negative A. Negative A. And then we have minus 3 is equals to 0. So it means that negative A should be equals to 3. Therefore, A should be equals to negative 3. So let's move on to 3.3. So in 3.3, we are given an inequality, right? So let's solve for x for the given inequality. So we've got 2x minus 1 is greater than 3, and 2x minus 1 is smaller than 7. So the idea with inequalities is we want to isolate the variable. So the first thing we can do is we can eliminate this negative 1. We can plus 1 to all parts of the inequality. So 3 plus 1 is 4. And 2x minus 1 plus 1 cancel out. 7 plus 1 is 8. I chose plus 1 because I know minus 1 and plus 1 cancels out. So we haven't yet fully isolated x. The next thing to do is we can divide throughout by 2. Divide throughout by 2. Once we do that, 2 goes into itself once, here twice. 2 and 2 cancels. 2 goes in there once and there 4 times. So it means that x should be greater than or equals to 2 and less than 4. So 3.4 says we need to solve for x and y simultaneously. So we need to set up a system of equations. So we have 2x minus 4y is equals to 6. We can call it equation 1. And 3x minus 5y is equals to 10. We can call that equation 2. So the approach that we're going to use in this given for these given equations is we're going to use the elimination method. We're going to try and eliminate x or y, but in order for us to do that, we need to have their coefficients for x or y to be the same. So we need to manipulate. So I think let's work with x. So the way to do this is you could list the multiples. You could list the multiples of 2, or let's try and find the LCM for 2 and 3. So you could list the multiples of 2, 2, 4, 6, 8, and so on. Multiples of 3, 3, 6, 9, 12. So you can see already we have the lowest common multiple. to be 6. So to get 6 for the first equation, you need to multiply by 3. You need to multiply by 3. And to get 6 for the second equation, you need to multiply by 2. So if you multiply throughout by 3 in the first equation, you get 6x minus 12y is equals to 18. And in the second equation, you get 6x minus 10y is equals to 20. So let's call this equation 3 and equation 4. So now we can eliminate 6 and 6. If you subtract equation 1 from equation 2, so 6 minus 6, those cancel. 6x minus 6x, those cancel out. Negative 10 minus negative 12 is the same as saying negative 10 plus 12, so it's 2y. And 20 minus 18 is 2. Divide by 2, 2 and 2 cancel, 2 and 2 cancel. Therefore, y is equals to 1. So you can substitute y is equals to 1 into equation 1 for the corresponding x value. So this becomes 2x. 2x minus 4 1 times 1 is equals to 6. And this is the same as 2x is equals to 10. Therefore, x should be equals to 5. So it means your x and y values for the given equation is 5 and 1. This is the point of intersection for the system of linear equations given there. So these here are your solutions. Right, moving on to question number 4. It says given that f of x is equals to 3x minus 6. So this here is a linear equation, right? We need to calculate the x-intercept of h. I think this should be f, and this also should be f. So we need to calculate the x-intercept of f, this function, and we also need to calculate the y-intercept. So we need to apply the dual intercept method. So we're given f of x is equals to 3x minus 6. So for y-intercept, you let x equals to 0. So let's do that. F of x, which is equals to y, should be equals to 3, 0, minus 6, then times 0 minus 6, which is equals to negative 6. And this here then becomes your y-intercept. Okay? And then for x-intercept, you let f of x equals to 0. So we can say 0 should be equals to 3x minus 6. So therefore 3x should be equals to 6. Divide throughout by 3. 3 and 3 cancel. 3 goes in there once, 3 goes in there twice. Therefore x should be equals to 2. And this becomes your x-intercept. So 4.1.3 says, hence sketch the graph of f of x, or f. We need to sketch this graph on a system of axes, clearly showing the intercepts. We need to show the intercepts with the axes. Okay. So let's plot or graph this function. So this here is your y-intercept. This here is your y-intercept. Okay. So the y-intercept is -6. So -6 is right over there. Let me use red for my intercepts. So this is -6 here. And then our x-intercept is +2, which is this point here. So we can join those 2 points. Join those 2 points. Let me do this. So this here is our graph f of x, right? So you can label this as f of x, and they asked us to label our intercepts. So this here is 2 and 0, and this here is 0 and -6. So let's move on to the next question. So in the next question, we're given a hyperbola, and we also need to find the x and the y intercept for h of x. So they say calculate the x-intercept of h, and 4.2.2 says calculate the y-intercept of h. So we can use once again the dual intercept method. So we can say for x-intercept, or intercepts in this case, because we have 2 roots or 2 solutions, we have 2 x-intercepts for a parabolic function. So for x-intercepts, we let y equals to 0. So h of x, which is equals to y, we substitute it with 0, is equals to 2x squared minus 8. So therefore 2x squared should be equals to 8. You can isolate the x squared by dividing throughout with 2. We're left with 4 here. Therefore x squared should be equals to 4. This implies that x should be equals to plus minus square root of 4, which is equals to plus minus 2. So these are sometimes called the roots, or the solutions, or the zeros of the of the parabolic function. These are called the roots or the zeros of a parabolic function. So normally a parabolic function at most has 2 x-intercepts, and sometimes it has 1 intercept. Right, so let's find, and at times also it doesn't have an x-intercept. Right, so let's find the y-intercept. So for y-intercept, for y-intercept we let x equals to 0, right? So it means that h of 0 should be equals to 2 multiplied by 0 squared minus 8. So therefore y should be equals to -8. 8. So this becomes your y-intercept. 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 This is your y-intercept, and these are your x-intercepts. Right. So let's use this, and we've once again applied the dual intercept method. So let's plot the zeros or the roots of the parabolic function. I'm going to use red for the x-intercepts. So it's positive 2 and negative 2. So negative 2 is there, and positive 2 is there. Those are the roots or the zeros of the function. And negative 8 is our y-intercept. So negative 8 is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8 is somewhere there. So now we can just join these points. I'm first going to start with a curve, and then I'll take it up, take it up, take it up. So this is what h of x looks like. This is h of x. So let's just label our intercepts. This is 2 and 0. This is negative 2 and 0. And this is 0 and negative 8. And these are called the roots or zeros of the function. So for question 5, we are presented with two graphs. We've got a parabola and a hyperbola. These are the graphs that are drawn, right? So for the parabola, we've got a standard equation. It takes the form of f of x is equals to ax squared plus bx plus c, where we know that c represents the y-intercept. Y-intercept, right? And then if you look at the hyperbola, it also takes the general form, which is g of x is equals to k over x plus q, where q in this case is the equation of the asymptote, right? Essentially, the value of q represents what the asymptote is. Not necessarily the equation, but the value of q. So y is equals to q would be your asymptote. So in this case, 1.5 is your asymptote. So they say A and B are the x-intercepts of f. So these are the x-intercepts of f, and C is the y-intercept. So C here is the y-intercept for f. And they also give us this point D, very important, is the point of intersection between the two graphs. So the two graphs intersect at point D. Right. So the first question says we need to write down the domain of G. So I'm just going to highlight G. So G is this function. It's a hyperbola, and we need to find its domain. So the domain is all the x values for which the graph G exists on the Cartesian plane. So we can use a vertical line test. So let's see for which values of x does this function exist. Remember, we're focusing on the purple graph, which is the hyperbola. So if you run your vertical line horizontally along the x-axis, you see it exists for all x values from negative infinity going, and then when we reach the y-axis, x is equals to 0, the function doesn't exist no more. But then once we cross the y-axis, or x is equals to 0, then the function exists for all the values of x. So the y-axis, or the x is equals to 0, then becomes your asymptote. It brings a restriction to the domain. So we can say then our domain is x belongs to the set of all real numbers, with the exception that x cannot be equals to 0. Because as we've seen, x is equals to 0 is a vertical asymptote, and this function doesn't exist in this region. So the next question wants us to find the range of f. F is the parabola. So I'm just going to highlight the parabola so that we can focus on it. So we need to find the range. So the range is all the y values for which this function exists. So let's do our horizontal line test. So if you run the horizontal line along the y-axis from y is equals to negative infinity, if you go up towards y is equals to positive infinity, you see that the function starts existing at c. So it starts existing at c, and then it continues to exist moving upwards towards positive infinity. Y is equals to positive infinity. So the range is such that it's all the y values from the minimum point approaching or going up to positive infinity. Y is equals to positive infinity. So you can see that from y is equals to negative infinity, going up until the minimum or the vertex, you see the function doesn't exist here in this region. But the moment you reach the minimum or the vertex, the function starts to exist. So the minimum starts, the range starts, or the function starts existing from the c point going up towards y is equals to positive infinity. So the range starts here, and the function starts existing at y at the minimum at the c point, and then it continues up towards positive infinity. So let's quickly determine what the y-intercept is. So if you look at our equation for f of x, we see that f of x is equals to 2x squared minus 2. So this here is your y-intercept, because it takes the form f of x is equals to ax squared plus bx plus c. So for the given equation, your p of x doesn't exist, but your c is negative 2. The constant is always the y-intercept. So it means the coordinates of c is 0 and negative 2. So therefore we can say our range should be y is greater than or equals to 2. And the next question says equation of the horizontal asymptote of g. Right. So let's have a look at G. So this is G. I'm just going to just highlight G again. So we saw for G earlier on that the vertical asymptote is the y-intercept, or x is equals to 0. So it means the horizontal asymptote is therefore going to be the dotted line. And we've seen in the equation given, g of x is equals to negative kx plus 1.5. We've seen that this here, 1.5 represents the horizontal asymptote. It comes from the general form, g of x is equals to k over x plus q, where q represents the horizontal asymptote. So in this case, it's 1.5. So the equation for the horizontal asymptote therefore becomes your horizontal asymptote then becomes y is equals to 1.5, or this is the same as 3 over 2. So that is the equation of the horizontal asymptote. And finally, the last question says, show that k is equals to 9. So k is this value here. To find that value is quite simple because we are presented with a point. So you can just substitute this point into that equation for x and y to find k. So let's check. When g of x is 6, it means the input should be negative 2. And this is plus 3 over 2. So this can be written as 6. Well, 6 can be seen as 12 over 2. This is equals to k over 2, because negative and negative cancel out, plus 3 over 2. So you can multiply throughout with 2. So this is 2 times that, 2 times k over 2, and 2 times. Remember, for this part, whatever you multiply, you need to multiply in the brackets. So if you're going to multiply by 2, you need to multiply both terms. So 2 and 2 cancel out, 2 and 2 cancel out, 2 and 2 cancel out here. So it means we're left with 12 is equals to k plus 3. Therefore, k is equals to 9, which is what we have here. So that is fine. Thanks for joining in. Hope this helped you. See you guys in the next one.